The first speaker of a conference is Dr. Seshaiyer, who will be talking on advancing AI for business by preparing the next-gen data science workforce. Dr. Seshaiyer is a tenured professor of mathematical sciences at the George Mason University. During the last 2 decades, he has initiated and directed a variety of educational and enrichment programs to foster the interest of students and teachers at all levels to apply well-developed research concepts to fundamental applications arising in STEM disciplines. In October 2020, he was invited to take part in Prime Minister Modi's Web initiative to discuss the future of data science education as a part of India's vision on AI for the future. Thank you so much for being with us today. Over to you, sir.
Wonderful. Thank you very much. Can I get a thumbs up if you can hear me?
Yes, we can.
Thank you very much. Would you mind sharing the screen?
Absolutely.
You too? Okay. Wonderful. Thank you very much. So, great. Thank you. And I'll just prompt you to go to the next slide. So thank you very much for this invitation. And thanks to Nilay and all the distinguished members here of the Ambani family for having us all come together for sharing best practices. Today I'm going to be sharing ideas on advancing AI for business, but from a perspective of training, and the training focused on data science. And so in the discussion, I'll try to talk about, the of AI with data science, machine learning, and so on. So of course, we all probably remember that artificial intelligence goes back to the 1950s, and the purpose was to describe human thinking and human intelligence as a symbolic system. So AI research was primarily centered around neural networks, inspired by the way neurons work in the human brain. But up until the 1970s, the field was booming with discoveries, but they were far from creating intelligent machines. So initially, they had hoped for a machine as intelligent as a human being would exist by the 1980s, that could read and understand the world around us and also reason as we do. But building some machines was not so simple. And because of limitations of computing processing power and so many different things. So, and that's when things like machine learning and science started to become very important. So I'm going to kind of talk about why data science education is a foundational pillar for advancing AI, for business, for a lot of things. So if you can go to the next slide, please. Thank you. So let me give you an example that I just received last month with my colleague. Imagine you are a drug addict and you just came back from rehabilitation, and you're sitting and watching TV, and all of a sudden a syringe comes up and you have the temptation to take drugs, going back to drugs. So your mental, your neurobiofeedback in your body is starting to tell you to go take drugs. And at the exact same instant, what if there is a device on your body that's tracking you, and that's actually sending all the data to the cloud, and the machine learning is processed, and then all of a sudden an app is triggered, and let's say and I'm the drug addict, and my best friend Nilay calls me and says, "Hey Padu, let's go for a coffee." So this idea of in the moment distraction is what we got the patent for. But just to let you know, I mean, this has many more applications besides just what I coded. But the idea is this is the convergence of a machine that is trying to read your neurobiofeedback and trying to understand data that comes out of it and the patterns, and recognizing and then trying to actually trigger an intervention at the moment that it's needed. And that's what it goes beyond AI for business, for impact. So I'm going to give you examples of that. So I just want start with this, which brings together data science and AI. Next slide, please. So as Nilay was saying, I was very fortunate to take part in the. I've never received a certificate from the Prime Minister's office, so this is something I just wanted to display. But it was really fun to actually discuss the future of AI and how data science education is going to play an important role in that we are going to hear all today from different distinguished speakers. Next slide, please. As I was saying, the artificial intelligence is a subdiscipline of computer science focused on building computers with flexible intelligence, capable of solving complex problems using data, learning from those solutions, and making replicable decisions at scale. That's the whole idea of AI. But data science, on the other hand, helps to create algorithms designed to learn patterns and correlations from data, which AI can then create predictive models that generate insight from the data. So the significant difference, I would say, is that data science involves pre-processing, analysis, prediction, and visualization. AI is the implementation of a predictive model to foresee events. That's the, if you were to classify the fine difference between the two. So as a focus, data science is about extracting meaning from structured and unstructured data to make informed decisions. And AI is the focus is to enable computers to perform complex intellectual tasks, humans, including decision-making, problem solving. So an application in AI could be, more descriptive, predictive, prescriptive, and, for example, customer trends, financial analysis, process improvement. On the other hand, the AI side is going to be about performing tasks like humans by learning, reasoning, and self-correction. So like chatbots, voice assistants, online gaming. So, while this is, there's definitely differences and similarities between the two. Next slide, please. So data science is really a cross-disciplinary set of skills, everything from mathematics to model and summarize data sets, to computer science to design and use algorithms to store, process, and visualize data, and also statistics as well, statistical thinking. And then there is the domain expertise, formulate the right questions and to put the answers in the right context. And so as the name suggests, it's all about data. So it's a multidisciplinary field which brings together even applications that look similar to AI applications. Like, for example, analyzing data collected by a bank, you may discover creditworthy customers or identify financial products that new customers buy. And then with the availability of volumes of data, more revenues could be seen. And using predictive analytics, it's also possible to identify hidden patterns in data. So, for instance, a travel e-commerce company may people flying American Airlines to Amsterdam opt for a luxury cruise tour in the city. So, and this is where you start to see the, descriptive analytics becoming predictive analytics to prescriptive analytics. So, and then you have Amazon telling you to buy and things like that. So next slide, please. So the US Department of Labor also organizes the competencies and performance criteria into multiple categories. For example, statistical and programming. This competency is very important for understanding data, learning some programming skills like Python, R, and things like that, being able to extract and visualize data. Then there is a competency on data science foundation. A data scientist must be able to characterize a business problem, formulate a hypothesis, demonstrate methodologies for a cycle that they have to implement. And then there is also about preparing data. 85% of the people in data science work on cleaning data. And it's very important to really understand how to construct usable data sets, identifying and collecting that data that's required, and so on. And then there's the model building. This is the stage, the core of data science execution, I would say, is where different algorithms are used to train the data, and the best algorithm is selected. And so the data scientist needs to know which ones to choose, how to choose, when to choose, and so on. And then there's the model deployment, which is where a machine learning model is valuable when it's integrated with the production environment, or to make business decisions when appropriate. And then there's the big data foundation. When we have to start to respect three big V's, which is the volume of data, the velocity of data, and the variety in the data. So these are very important things to respect. And of course, in leadership and professional development, data scientists must always be good problem solvers. So it's very important for them to understand concepts of analyzing risk and making improvements. So failure is a very important part of the process. Next slide, please. So it's also important for people to realize when we, think about data science to AI, this idea of 6 Ds in exponential growth. So it's like a roadmap that shows what can happen when an exponential technology is born, right? So not every phase is easy. And the classic example of Kodak, which invented the digital camera in 1975, it didn't heavily invest in new technology. And so even though in 1996, they had a 28 billion market with 95,000 employees, by 2012, they were bankrupt. When somebody by the name Facebook acquired Instagram, and which is a digital photo sharing app. So the idea of that taking risks. So when something enters digitization, it enters this exponential growth that we see in computing. So this information is easy to access, share, and distribute, and it can spread like the speed of the internet. So it's very important for us to understand whether it's music or biotechnology. As long as it's represented by ones or zeros, this one needs to understand the idea of how it goes from digitization, how one needs to be disruptive, and that's what Kodak was not. Did not try to be disruptive in the market, and so trying to be disruptive, taking that risk, and then going into the phase of phase through demonetization and all the way. So I think, and at the same time, as I said, the 3 V's are very important to respect in this growth of any technology. Next slide, please. So, and then there is the data, enterprise workflow, which kind of mimics AI. It leads that AI enterprise. I would say it's an AI enterprise workflow where you need to understand the business opportunity. You need to work with data engineers and IT department to find the right data sources, prepare the data, build the machine learning models, specialized AI models, and then assist the deployment of these models into the operations of the organization, then measure the success and communicate back to the business. This is kind of the full life cycle. Next slide, please. In the data science world, this translates to how do you actually capture, that is data acquisition, data entry, signal reception, data extraction. How do you maintain the data warehousing, cleansing, data staging, data processing, data architecture. How do you process the data, which is data mining and clustering, modeling, and summarizing? And then how do you actually analyze the data, which is where the mathematical, statistical, predictive analysis, regression comes in? And then how do you communicate with the data, which is the reporting and visualization? So all these pieces need to be done really well, independently, as well as come together together. Next slide, please. And as I prompted before, it's we need to understand what's happening in the company or what's happening in my business. That's descriptive. Why is it happening? That's diagnostic. And then what's likely to happen? That would be predictive. And then what do I need to do? That would be prescriptive. So, we need to understand all these different data science and AI analytics when we are working with, developing new technologies. Next one, please. So I happen to spend time with Windsurf. As you may know, he's number 3 in Google, who is known for his development for TCP IP protocols, the technology communication protocols. So I spent some time with him, and I asked him, like, hey, Wind, if you type education makes me on Google, what do you think? think it'll say. Of course, you're all thinking right there, you're all very distinguished. Everybody's thinking like, oh, of course, education makes me smart. Of course, education makes me, I would probably do a poll on chat right now. And it'll be very surprising to, most people are thinking, of course, it has to be good and all that stuff. Next slide, please. You'll be very surprised when you try this in Google. The very first response is depressed. And it's very surprising, right? So this is the mother of all search engines. I mean, the best machine learning algorithm ever. And it's telling you depressed. I mean, this is churned by all over the world. And so you start, what are we making mistake? What mistakes are we making in education? Are we giving the students what we want? I mean, it's gone are the days where we can treat students as consumers of education. Students are producers of information. They're peer reviewers of information. So we need to really live in the world of exchange of information. And so as educators, we need to become facilitators rather than just standing in front and showing our rears and teaching. So it's a very important thing. And so I was very happy to see that video where the teacher was not standing in the front and teaching, but they were actually moving around, which is more more student centered. So which is great. So I just wanted to, this is a wake up for us to really turn the way we preach. Next slide, please. So when I say that, what I mean is, yes, content is very important. Content-focused education is very important. The traditional STEM disciplines, science, technology, engineering, arts, mathematics, all is important. But right now, competency-based education is also very, very important. So that gives you not just the traditional skills, but the transferable skills. And data AI is in that the whole transferable skills part. And I think more universities must invest in this aspect of competency-based education. And then, of course, associated with that could be not just degrees, but things like micro-credentials and all that. So next slide, please. And when should this start? It should not start in graduate school. It should not start as a faculty. So I decided to go back all the way. So I work, I'm the STEM advisor for the governor of Virginia. And the last 2.5 years, we developed the first ever high school data science course. The only other course is in California with Stanford and also UCLA, but they are doing it more on a statistical approach. What we have created is the first organic course. I'm happy to share how, and students leaving understand data in the society, data around them, data communication, the cycle of data, and it's created by teachers for teachers. And the high school students are leaving with understanding of Python and applying it to real world problems and like data trafficking, and applying it to understanding the situations around them. So next slide, please. So here's a data cycle that we follow where everybody understands how to collect data, process data, analyze data, visualize data, and interpret and predict with data. Next slide, please. So some key components that we integrate in this course is computational thinking with fundamental pillars of pattern recognition, abstraction, problem decomposition, and algorithms. And there's lots and lots of examples that we get students to think about. Next slide, please. And we also integrate 5 important aspects of AI perception, how computers perceive, like our senses. We start from early on to reasoning and representation, to learning, to natural interaction, and the most important of all, societal impact. Next slide, please. The societal impact is where AI makes a big difference. And this is where I want to connect to the United Nations Sustainable Development Goals, which is a blueprint for, solving the global challenges. And so I want to leave you with a global challenge. I know we are here to talk about AI for business, but I want to give you a challenge to all those listening here. Next slide, please. So about, so these are all challenges from poverty all the way to partnership. So if you can go to the next slide, please. So is the problem of open defecation getting better in India? That's the question. So about 344 million people don't have access to toilets, regular toilets in the country. I have to say that Swachh Bharat has definitely, and with WHO and UNICEF, they report, open defecation is definitely, the practice has become much better. About since 2000, but there's still work to be done. So when we have algorithms like Uber that knows exactly where to go and deliver, or where to take a passenger, or where to go and Uber Eats to deliver food, why can't we have algorithms? Why can't we have machine learning algorithms to figure out where to place the next generation mobile bathrooms? So I encourage students here to really think ahead of using machine learning and other things on AI, not for just research and their own satisfaction, but for the user's satisfaction. And so a human-centered approach to problem solving. I do teach a course called Design and Systems Thinking. So I'm trying to bring design thinking and AI together so that we can solve problems not for ourselves, but for the society. Thank you. Next slide, please. And I think that's the last one. Thank you.
Thank you so much for that insightful session, Dr. Seshaiyer. And we've received some questions regarding your session, and I'll just take up a couple of them. The first question reads that, are there data science developments and AI applications trends that focus on democratizing classical music compositions?
Wow. That's such a wonderful question. Yeah. So, if you know, classical music is all going back to octaves, and octaves is all going back to the golden ratio. So yes, there is a lot of mathematical thinking and statistical thinking around it. Although there is no set data science curriculum for it, but I think your question goes to, I can think of, how you can actually use music if you just want to think of it as AI for understanding which type of music and things like one version. I can even think of, music for curing certain things. And, when the right music is played for the right purpose, I think that is where AI can really stand a chance, make a difference. In fact, that question of the original example of the drug addiction, we are actually test music that the person likes. And so at the time they want to take drugs, we play the exact music. The app can play the exact music. So yes, there are applications that are in that area.
Thank you so much, sir. We have a couple of questions regarding the same domain, and this is my last question for you. And they talk about how AI will play a role in project execution, and will it be helpful in the domain of project execution?
Absolutely. I mean, there's no question. And I would say, right from when you do think of a project, you go through these steps, like, you first empathize and the needs assessment, then you do define the problem statement, then you ideate solutions, then you prototype, what you want to do, and then you test it. But at each of those steps, we need to be checking, is this the best one? Yeah, are we making mistakes? And I think that idea of failure, bringing in the risks that you take, and I think AI is going to play a very significant role in each one of those steps. Absolutely.
Thank you so much, Dr. Seshaiyer, for this wonderful session. It was a pleasure to have you with us.